Hi, welcome to this video. Okay, so in this video I'm gonna show you guys how to solve questions involving proof. Okay, so by now we should be pretty comfortable with the identities that you see on the screen right now. So we have tangent theta equals to sine theta over cos theta. Sine squared theta plus cosine squared theta equals to 1. Sine of 2 theta is equal to 2 sine theta cos theta. And for cosine 2 theta, we have cos squared theta minus sine squared theta. Or I can write that as 2 cos squared theta minus 1. Or I can have 1 minus 2 sine squared theta. So all of these properties, identities, we should be pretty comfortable with them now, because we will need to use them for questions like the one we have over here. So what I'm going to do is I'm just going to copy all of them. Right? I'm going to copy all of them and paste them on the next slide. Okay, so I'm going to pause the video and I'll be right back. Alright, so you see that I have just copied the identities on the top right corner of the screen. And let me do the same thing here. Okay, so you see that I have the exact same thing on both pages, and that's because when we are solving questions involving proof, there are two different methods for us to do it. Okay, so I'll try to show you both in this video, but if it's too long, if the video ends up to be too long, then I will cut it up into two different videos. Okay, so now let's just get started. They want us to prove that the entire left-hand side, 1 plus tangent squared x multiplied by cosine 2x is equal to the right-hand side, 1 minus tangent squared x. Okay, so it looks like a lot of stuff to be completed, and we have never really done proofs before, right? So this is the first time. And when we are dealing with questions involving proof, we have to choose one side to play around with, okay? And in this case, I'm going to choose the left-hand side. I'm going to choose the left-hand side. I'm going to choose to mess around with my left. So let's see what we can do here. So the first thing that we should see is we have this cos 2x, and maybe later on we'll need to use that to help me, right? But I don't have anything for this 1 plus tangent square x. But I do have, I can use this tangent theta is equal to sine over cos. I can use that to manipulate this tangent square x, and I'm just going to do that. Then let's see what happens. So 1 plus, this would be sine square x over cosine square x. This whole thing multiplied by cosine 2x. Okay, and we're gonna do a bunch of other stuff, and hopefully in the end I'm gonna get 1 minus tangent square x. Right, hopefully we can get that in the end. So let's see what else can we do after here. I'm going to see, I'm going to distribute it now, and let's just see what happens. So I'm going to have cos 2x plus sine squared x over cosine squared x cos 2x. I hope you guys see that I cannot cancel them. Okay, they are very different. All right, this is cosine of 2x, this is cosine of x. In fact, I should put a parenthesis there too. So that's cosine 2x, this is over here, this part, that is cosine x squared. Okay, the base is cosine x. Alright, whereas over here, this is cosine 2x, okay, cosine 2x. So it's very, very different, alright? So please don't make that mistake. There's nothing I cannot say I cut them out, okay? Alright, and now let's see what we can do here. I'm going to, I am going to combine them into a big fraction. I'll have cosine square x at the bottom. Alright, and on the left hand side, I'm gonna have cosine 2x multiplied by cos square x. And does that bring us any good? Maybe not. Let's see what we can do, because I'm hoping that maybe I need to get this 1, right? I need to get that 1, and I need to get this minus tangent square x. Sometimes I can mess around with my right hand side, change the way it looks a little bit. So I can change around with that sine square, tangent square x, make that into sine square x over cos square x. Right? So maybe later on I can get something like this, and that will bring me to this thing that I'm trying to prove. Right? So we are kind of stuck, but we have not really tried everything yet. So I'm going to leave that cos 2x there, plus, and I'm going to leave this sine square x over cosine square x. I'm going to leave that there, and I'm going to mess around with my cos 2x. My cos 2x can be equal to, I'm going to use, so hopefully I have something that I can cancel with my denominator. So I'm going to use this one. I'm going to use that one right there, 2 cos square theta minus 1. So when I distribute this, hopefully I can cancel some stuff out. So cos 2x, haven't changed it yet. So multiply this, that gives me 2 sine square x. Right? Let me just show the steps, I think that's better. So this is sine squared x over cosine squared x multiplied by 2 cosine squared x. Okay, this is what I get from here. And then the next part, I need to distribute the next part. I'll get sine square x over cosine square x. Multiply that, so the 1 just becomes minus 1, minus that. Okay, and you can see that the cos square and the cos square cancels out. When they cancel out, they don't become 0, they become 1. So I have cosine 2x plus 2 sine square x minus sine square x over cosine square x. Okay, you see that here? Isn't this part? Isn't that equal to that part? Do you see that? Do you guys see that? So when we are trying to prove stuff, we have to be very mindful of every step. After every step, always take a look at where you are trying to get to and see if there's anything that could give you what you want, right? So now I already have this minus sine square x over cos square x. I already have that, which means this whole chunk in the front, that has to be your 1. This is the 1 over here. Does that make sense? So now all we have to do is to figure out a way. We need to manipulate this whole chunk, and somehow we can get that to become a 1. So let's see what we can do. Cos 2x, I'm going to, okay, I know what to do. I'm gonna use this one for now. And you might ask me why? Because if I replace my cos 2x with this one, with this right here, I will get a minus 2 sine square x. The minus 2 sine square x, which will be cancelled out with that one over there. So that's my reason why. So I'm going to replace cos 2x with 1 minus 2 sine square x. This is my cos 2x. And then I'm going to have plus 2 sine square x minus, so sine square x over cos square x becomes minus tangent square x. Okay? Minus 2 sine square x plus 2 sine square x cancel out. I will end up with 1 minus tangent squared x. So I have just completed the proof. Yay! Alright. So, as you guys might have noticed this, when I'm trying to get this proof, I am sort of doing trial and error, but I'm not just doing it in a way without plan. I was being very observant. I look at the properties that I have here, right? I look at them and see if there's any way for me to combine them. And also every step I would keep on referring back to where I'm going for, right? Where I'm going with them. And the ended up that I have this part is the same as that over there, which means the one over here would be this whole chunk in the front, right? And that's kind of the focus after a lot of steps before that, right? Sometimes when we are dealing with proof questions, luck kind of plays a role, and you do have to. A lot of times you won't be able to get it right away. So don't feel discouraged. Just keep trying with the different properties we have here. Keep trying them out. Eventually, one of them at least will be able to bring you somewhere that you want to go to. All right. Okay. I will show you guys another way of doing it. In the next video. All right. Feel free to rewind, and I'll see you. Bye bye.